Okay, so a very good morning, students. Hopefully, I'm audible to all of you. So basically, I was not having a class with you all today. I was given a class because Shikanda ma'am was a bit busy, right? So what I have planned to do today is, since yesterday only we had a class and I had explained your conversion of a grammar to like regular grammar to a DFA and vice versa, and I guess I had also discussed the removal of epsilon moves from an epsilon NFA, gave you a recorded lecture. So it's fine with that. I'm not going to talk about that. What I have planned for today's class is, let us practice few questions. Okay, so I have selected like 4 questions from which are common in your GATE examination, common type of questions. So the same has also been posted in your Google Classroom. If you check your Google Classroom, I have already posted it as an assignment. Okay, so what I will do is, let me share my screen and just clear the questions to you a bit. So if you check your Google Classroom, you can find this assignment. Hopefully my screen is visible, right? Is my screen visible, students?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, thank you. So if you look at the first question, it's asking that the minimum possible, you have to find the minimum possible states of a deterministic finite automata that accepts the regular language L of the form W1 A W2, where W1 and W2 belongs to A comma B, that is, it consists of the alphabet set A comma B. The length of W1 is strictly 2 and the length of W2 is greater than or is equal to 3. Like, it can be is equal to 3, it can be greater than 3 also, like 4, 5, 6, anything. So what you need to find over here is, you have to construct the DFA. Basically, you have to construct the DFA and like find out the minimum number of steps that you require to get this kind of a language. Okay, so I will open the canvas, but I'm not going to do it alone. I need some response from your end. So I'll again open the question. We have a language which consists of A's and B's. The first part of the language should have a length of 2, then B should have a A, and then the length of the other part should be greater than or equal to 3. Okay, it's a simple question, straight cut question. So let us start with constructing the DFA, and so let the initial state be A. Okay, acha. Now I am not going to draw it alone. Tell me, what should I do after this? Like what transition should I take, or what move should I take? Suppose the next state is B. The next state is B. Now for the state A, what should be the A and B transition, like alphabet set A and B transition? Where can I give it? Should I put a self loop, or should I put a A over here, or should I put a B over here? What should I do? Think a bit, tell me. At least try to answer, because these things are not new to you. We had practiced constructing DFA long back, so this should be quite easy for you to answer. At least you can give some answer. Need not be correct, but at least try. initial part, the question in the initial part, it's totally mentioned that the length of W1 is strictly 2. So for getting a string of length strictly 2, we will require at least 3 states. And since it's strictly 2 and the alphabet set consists of A and B, so we can just write A comma B, then again A comma B. So we are getting a length of 1 over here and length of another 1, so 1 plus 1 2, and we are in state C. After coming to state C, what was the next thing? Next we will encounter a. There must be a. So when it's a must thing, we will directly put a transition for A and we will move to some other state. Now what if I get a B? B is not allowed over here. B is not allowed over here, right? So what I do is I simply put a trap state, right? I can put a trap state. Achha. Now the initial part of the language is done. What about the next part? It's said that the length can be greater than or equal to 3. So for greater than or is equal to 3, again, how many states shall we require? Let us see. Sorry. Yeah. So from D, we can move to E with a transition of A comma B. From E, we can move to F with a transition of A comma B. So a length of 1 and 2 done, and we need at least a length of 3, right? So another state will be required. Name it G. Name it G. Now it's said in the question, or it's mentioned in the question that we can have a length of at least 3. Like greater than is equal to 3. So if it's is equal to 3, it's fine. If we want something greater, we can simply put a self loop, right? Sorry. You can simply put a self loop for A comma B, and obviously this is your final state. G is your final state. Okay. Now this is the DFA which we are getting, and let me tell you, if you try to minimize this DFA, you will not be able to minimize it to any other level. Why? Because it's very evident from the diagram that for getting a length of at least for this portion, for getting a length of at least 2, this much is required. Then for the middle portion, this much is required, and again for length of at least 3, this much is required. And like you cannot avoid this part, so there is no point trying to minimize the DFA. And obviously, since in the middle portion A is specifically mentioned, whenever you encounter a B, you must go to a trap state, so one extra state for that will be required. So total number of states is 1, 2, 3, 4, 5, 6, 7, 8. So we get 8 number of states. And again, if you want to try, you can try reducing the number of states using the DFA minimization process that I had shown you, but it's in vain. It's of no use, because you won't be able to minimize it further. Like you won't get a number of states lesser than 8. Okay. So is the logic clear? How am I constructing that? It's a very easy one actually. Still, is the concept clear? Is the logic clear, all of you?
Yes, ma'am.
Okay, fine. So let us move to the next question. So this is the next question. This is the diagram for the next question. Okay. So consider the DFAs M and N given above. So this is a DFA M and this is a DFA N. the number of states in a minimal DFA that accepts the language LM intersection LN is. So basically you are asked to find the intersection of these two languages. Because this is a DFA, it would give some language. Again, if this is a DFA, it will give some language, and then the intersection of the language you have to find and construct the corresponding DFA for that, and then you have to state the number of states in that minimal DFA, obviously minimal DFA. Okay, so can you just tell me what should be the approach of such a question? There are two DFAs, you are asked to find the DFA after you intersect these two DFAs, and then the number of minimum number of states of that DFA. So what should be the approach? See, you might be right, wrong. Please try. Anyone, please try.
Ma'am, for DFA, MN and we will try to make the language. Means write the language for M and N.
Okay, yeah, correct. Yes. So for M, if you look at the DFA, what kind of language is M like accepting? What kind of language? If you look at the DFA M, what kind of language is M accepting?
Ma'am, at least one A.
Yeah, at least one A, or in in other sense I can say ending with A.
Ending with A,
Ending
yeah.
with A. Okay, that would be the appropriate one. Now on a contrary, if you go to N, what is the kind of a language accepted by N? It's
Ending with
ending
B.
with
Ending
B.
with B.
Okay. So think logically, there are two DFAs, one is ending with A, one is ending with B. If you try to intersect these two kind of a language, what are you going to get?
Ma'am, nothing.
Nothing. Null. Zero. Nothing you are going to get. So if such a question comes and you are asked to construct a DFA and state the minimum number of states, then simply what you need to do is just a second. Yeah, since you are asked to draw a DFA, you must draw a DFA. So here's your DFA. Give some name. There should be no accepting state. What is the alphabet set? A comma B. So this is a DFA which is no accepting state. The alphabet set is A comma B. So you can say that it is accepting a null or input string whose length is epsilon, like empty string, right? So for such a question, if you try to answer, just a trick, it's not zero. You should not answer that the number of states in a minimal DFA that accepts the language LM intersection LN is 0. 0 won't be the correct answer, but 1 will be the correct answer, because you have been asked to construct the DFA. You have to construct the DFA. A DFA is possible, but since the language is not possible, it's a null language, you do not put any accepting state or any final state. There is only one initial state, and just put a self loop across that initial state. So since it's not having any final state, we can say that it is a DFA which accepts an empty string, which actually suffices your purpose. Okay. So for any question of this kind, you can follow this strategy. If somebody thinks in this way that I will try to do the intersection, like suppose this is A and this is B, this is C and this is D. So if somebody tries to intersect like AB, AC, AD and BC, BD, it will be a cumbersome process and you might end up in a wrong answer. So the first thing you try to do is that is deciding the language that the DFA is accepting. If you cannot find any relationship between the languages, then go for that process where you go for that intersection of DFAs, or getting the cross product of the DFAs and doing the process in that way. Okay. Otherwise, first thing you try to find the language. Okay, so moving to the next question, question number 3. This is again very easy. This is the given NFA, right? This is a given NFA, and you have been asked to what is the set of reachable states for the input string 0011. So what is the set of reachable states for the input string 0011? Now this is very easy. I want the answer from your end. Tell me.
Q1, Q2, Q0, Q1, Q2.
Yes, correct. Now, why Q0? Because suppose 0011, so there is a self loop. I can have 0011. Therefore, Q0. Why Q1? I can have 001 and then a 1. Therefore, Q1. Why Q2? I can have 001 Therefore, Q2. So, three possibilities, like their set of three states are reachable, which are Q0, Q1 and Q2. Okay. Achha. Fourth one. So, what is the complement of the language accepted by the NFA shown below, like shown above? Sorry. Assume that the alphabet set is A and epsilon is the empty string. Okay. So, one thing, students, I might have told you that for getting the complement of a DFA, what we do is we make the final states as a non-final and the non-final states as the final state. But that is true for DFA and not true for NFA. Okay, we cannot get the complement of an NFA by changing or interchanging the final and non-final states. So for this particular question, if you think logically, from the perspective of the language, what is what should be your answer? You have to find the complement of the language accepted by the NFA shown above. So this NFA accepts which language?
A.
Not only A,
A.
it's A plus. It's a A, like you have A star, that is clean closure, but it's at least one A. So you can have one A, 2A, 3. It's a kind of loop because these are epsilon transitions. So you can have multiple numbers of A, but at least you should have one A. I can write it like this. A plus, if you remember this, we have A, we have AA, we have A, and so on, right? So, if this is the language which is being accepted by this NFA, what will be the complement of this language? If this is the language, what will be the complement of this language?
Man, epsilon.
Agam, correct. It will be epsilon. Why? See, whenever we are complementing a language, what is the superset? The superset is always A star, like, so A star consists of epsilon, comma A, comma AA, and so on. Now, if this is A star and this is A plus, what is the difference between them? Difference is epsilon. So the complement of it will be epsilon, which is not present in the NFA. So if this NFA is accepting all the languages of the form A plus, then the complement of this will be epsilon, because epsilon is the part which is left out of the universal set of this. If the universal set is this one, so if you try to find the difference between this and this, you will get epsilon. So any NFA which is constructed as a complement of the given NFA, it is going to accept a string, empty string rather, epsilon. Okay. So I just had this 4 questions for today. I request all of you that since I have posted this as an assignment in your Google Classroom, see, I have done this, you have listened to it, but in future you might tend to forget this thing. because every day you are going through many classes, you are solving many problems, so it might happen that you forget. So for your own benefit, I am telling you that try to solve this. You can just write it down in pen and paper and scan it and upload it, or if you want you can use a word file and write it in your own way and upload it, whatever you are comfortable with, but at least submit the assignment. Okay. And I also have a IMCRP test for you. I've given the test code. Just somebody confirm me whether the test code is working or not, because from last few days there's some problem with the test code. So can someone please confirm whether the test code is working? Okay, okay, fine. So that's it for today. Basically, I
Ma'am, can you move to question number one?
yeah, sure.
Ma'am, in question number one, there's given language W1A W2 slash W1, right?
No, no, it's not slash. See, it's W1A, W2. It's
Slash
no, 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 no.
W1.
It's not a slash. What we do in a, like when we are representing something inside like curly braces, here you're giving the conditions. This portion is your condition. This is your language. You give a pipe and give the
Oh,
condition. Okay.
oh, I thought W1 is a
No,
termination
no, 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 no,
condition.
no.
Oh,
Yeah.
okay.
Okay, so submit the assignment, take the MCRP test, and you can leave the meet. Okay, this was all for today. Thank you. We'll meet you next week.